We're solving problem 18 from the 2021 Fall AMC 12B. Set u of u0 at 1/4, and for k is greater than or equal to 0, that u of k plus 1 be determined by the recurrence u sub k plus 1 is 2 uk minus 2 uk squared. This sequence tends to a limit, call it L. What is the least value of k such that the absolute value of uk minus L is less than or equal to 1 over 2 to the power of 1,000. So what we have here is a recurrence problem, and we want to basically test a few, or plug in this first value to get our other secondary values. So if we just do this once, u0 is 1/4. If this is 0, that means that u of 1 is equal to, well, just in general, if it's uk plus 1, we have, well, we can take this equation and factor out a 2 times u sub k to get 2u of k is times 1 minus u of k. We can then plug in our value that the problem gives us, where k is equal to 0, so u of 1, since you're adding the 1, is equal to, well, 1/4 times 2 was 1/2 times 1 minus 1/4. And this is 3/8. Doing this again, for u sub 2 will result us in 15 over 32. You can do this again for the third recurring term of u3, but this might be a hard to spot pattern, but it's there. We see that 3/8 is equal to, well, when we multiply this out, this is 1/2 minus 1 over 2 times 4, which is 8, but we can factor out that as 2 to the 2 cubed. 15 over 32 is, again, 1/2 minus 1 over 2 to the power of 5. So it seems that every recurring term seems to have, like, being subtracting a increasing factor of 1/2, and so this limit gets closer and closer to a value, desirable value that we want. Now, by doing this again, we see that our limit, it's approaching 1/2. So if it's approaching 1/2, we can then know that the limit is 1/2. And, well, since we know that this is true, we can say that if you take the u2 term, right, this is 1, you do 1 minus u of 2, this is going to be 1 minus this whole thing, 1/2 minus 1, 2 to the power of 5. This is equal to 1/2 plus 1 over 2 to the power of 5. And why is this value desirable? Well, this is because we want a value that's really close to 1/2, and it gets infinitely close to it, so we can use this as a value for what we have over there. Now, what we do know is that for this right here, we can rewrite it as absolute value of 1/2, and then it's going to be plus a recurring term, which is going to be 1 over 2 to the power of k plus 1, minus our limit, which is 1/2. And this is all less than or equal to 1 over 2 to the power of 1,000. These 1/2s cancel out. This is a minus. And then, since it's the absolute value and you want to switch the signs here, that's what you tend to do. This is 1 over 2 to the power of k plus 1 is greater than or equal to 1 over 2 to the power of 1,000. Since these are both like powers of 2 in the 1/2 part, we can say that 2 power of k plus 1 is greater than or equal to 1,000. So that means our desired value, least value of k is 10. And that is our answer for this problem.